Very good morning to all. This recording I have created for the students, those who are absent for the first few lectures and those who are lagging in the engineering drawing course. So today we will see one more problem on projections of plane, wherein I have written the problem statement over here on the drawing template. This drawing template you can download from the Moodle. We already discussed this, how to download this template from the Moodle. So after downloading the template, here in the bottom nameplate, you can fill the details like date, then your name, roll number, the title of the sheet, sheet number, and drawn by. So after filling all these details, you can start solving the problem statement. Here, I have already mentioned some of the tools which are required for solving these problems, like line, then dtext command, circle command, divide, properties, copy, rotate, dimension angular, dimension aligned, polyline, match property, rectangle command, multi-line text command. So if you practice all these 10 to 12 commands, you can easily solve any problems related to projection of line, plane, etc. So let us start solving this problem. A problem statement, I'll just read the problem statement for you. A circular lamina of radius 25 mm is resting on a point of its surface in HP. So if you read this first sentence, you'll understand that the plane is circular plane and whose radius is 25 mm and it is resting on one of its circumferential point in HP. So it is HP resting problem. So whenever it is HP resting problem, you have to assume that initially the plane is parallel to HP. So whenever plane is parallel to HP, the true shape of that plane will observed in the top view, or you can say in the HP itself. Okay, next statement is draw its projections if surface of the lamina is inclined at 45 degree with HP. So always while solving the plane related problem, second step is always related to surface inclination. So in the second step, you have to incline the circular plane by making surface inclination 45 degree with respect to HP. And then in third step, it is mentioned that and top view of the diameter. So top view of the diameter means the top view that you obtain in the second step and its diameter through which resting point the through resting point is inclined at 45 degree with VP. So in third step, the top view diameter that you obtain in the second step, you have to copy and rotate in a such a fashion that top view diameter should make an angle 45 degree with VP. So this is what the three steps that you have to solve. Now let us start with solving this problem. So since the plane is circular plane and when you assume that the plane is parallel to HP, so in the top you will get the true shape. True shape means circle. So now use circle command. So here in the draw toolbar, you find the circle or simply type C, enter, and it will ask you, you can read this hint which is provided in the command window, specify the center of point for circle. So directly click the area below XY line and just move the mouse. So it will generate the circle. Now either you can give diameter of the circle or radius of the circle. But if you read this command window, it is asking you specify radius of the circle. So in the problem statement, radius is given, so 25. So type 25 and then now after typing radius 25 and enter, it will generate a circle. So this is the circle. Now, since this is a circular lamina, to get its different projector points in the front view, we have to divide this circle into some equal parts. Now, why we are dividing the circle into equal parts? Because in the later stage, the circle, when you rotate by certain angle, it will not look like a circle in the second top. So to obtain that second top, which may be an oval shape, so it was quite difficult to draw that oval shape. So that's why initially you have to divide the circle into some equal parts, and from that parts you can easily draw the oval shape in the later stage. So let us divide the circle into some equal parts. Say for example 8 equal parts. So how to divide the circle into 8 equal parts? So command name is divide, which I have mentioned in the list of the command. So command name is divide, D-I-V-I-D. You can see here on the screen, D-I-V-I-D. Then enter. It will ask you to select object. So click on the circle, left click. Then it will ask you enter the number of segments. So how many segments? We want 8 segments. 8, enter. So directly the circle will get divided into 8 equal parts. So now why these points appear on the screen on the circle? The reason is in the format under point style, you have already set the point style to this. Then point size is feet and set size in absolute units. So whenever you solve the problems, first setting, if it is not done, in the template, you have to set this point style to the required point style and of required size by setting size in absolute unit. Then only the points will appear like this. Okay, so after dividing the circle, let us project this to obtain the front view. So whenever when you see the circle which is parallel to HP from the front, it will look like a simple line. So how to draw that? Just by projecting each and every point vertically upward, you'll get the line. But before that, let us label all these points by DT command. DT. After entering DT, it will ask you specify the start point of text. So where you want to type. So I want over here. Now after clicking there, it will ask you to just read this command window. Specify height. So I have mentioned it is 6. If you want to change it, you can change. Say for example, I want 5. Enter. Specify rotation angle. Now it is asking you specify rotation angle of text. Always keep 0. So 0, enter. And now the position where you have already clicked, it will appear one text box wherein you can type the text. So now I am labeling this point as A. Now here B, here it is C, then D, then E, then F, G, and H. Okay. And then here you can click at the center and you can mention this as a true shape. Now after entering each and every label, click outside this box and then escape. Then only that DT command will get executed. Okay. So now labels are over. Now each and every point you have to project upward to obtain the front view. So now command name is, next command is line command. So L is the shortcut, L, enter. Now from which points? A point. So click on the A and then sorry, click on the A and then click on perpendicular symbol on XY line. It will draw a line. Then spacebar. Spacebar is the key to exit and to enter the command. So once again, if you press the spacebar, you can repeat the same command. So spacebar from which point? This point and up to the perpendicular symbol. Again, line enter or spacebar. from this point up to the perpendicular symbol. Then again line command by spacebar, this point, this spacebar, from this point up to this. So likewise you'll draw the lines from each and every points. No need to draw the projector from B, C and D, because these points and lines you are projecting from these points will get overlapped with the lines that you have drawn through H, G and F. Now mark the points, intersecting points, to get the front view of this circular plane. So command name is PO enter because we want point PO enter, where first this point, again spacebar to repeat the command, again here spacebar, again here spacebar, again here spacebar and here. Okay, so now if you join these all points by line command L, from where, from this point up to this. So this is edge view of the circular plate, because from the front the circle appears to be a straight line. Okay. Now label these points that you have already marked over here. Again use DT command, D T enter. Location is over here, then enter. Then you mention this point as A dash. Here this is B dash comma H dash. Here you can type C dash comma G dash. Then here D dash comma F dash, and last point is E dash. Also mention this front view as edge view because it look like a edge view, and click outside and then escape. So this is the front view of the circular plate. Now you can change this projector to color line because we want this projector faint. So you can select any of this line, you can select any of this point and select the bilayer from the properties, then select the color, and you can type here 9, only 9, and press OK button. So this selected line becomes color 9. Now you can change the property of this by match property, change the property of the remaining lines in this fashion. Also you can change the thickness of front view and top view by selecting and changing the thickness. This thickness change will only observed when you click LWT option under the status bar. So this LWT, just look at the cursor location, LWT, this should be on. Then only this changing thickness will appear. Now, first step is over. So in first step, we got circle in the top view because you have mentioned that circle is parallel to HP. So in the top view, you get the circle, and in the front view, you get the edge view. Now, read the problem statement. What is mentioned that draw its projection if surface of the lamina is inclined at 45 degree with HP. 45 degree with HP. So this inclination of circular plate with respect to HP is observed in the front view. So you have to make changes in the front view. In short, you have to rotate the front view by 45 degree with HP, because inclination with HP is always observed in the front view. So what I'll do, I'll just copy this front view from this place and I'll place it here, and then I will rotate it. So command name which is required to copy, CO, shortcut is CO, command name is copy, enter. Then click and select this object. So while clicking, you have to click outside so that the entire object, the things that you want to copy, it should come inside this blue box. So click here, the second click. Then right click is compulsory. After selecting the command, after selecting the object, you have to click right, and then from point where you want to copy, I want to select A dash point. So select A dash, and the destination point, I want to place it here. So click here then, and then escape button. So this is the copy command by which I have copied this front view over here. Now rotate command to rotate, because the surface is inclined and that surface inclination is visible in the front view. So RO enter. Again the selection by same method, you have to click here so that, and click second here so that this entire thing will come inside this blue box. Then second click, then right click is compulsory, and you have to select this point, A dash point, and give the angle 45 degree. See, the 45 degree inclination is always in clockwise, and since uh, we want only in anti-clockwise, so 45 directly you can put. But if you want clockwise, but if you rotate it by clockwise, the edge view will come down. So by default 45. If you view minus 45, this edge view will rotate in clockwise direction. Now see, edge view is rotated by 45. Now you can give the dimensions by using dimension command. You just click on the dimension menu bar, click angular dimension, select this line, then select XY line and click over here. It will give you dimension 45. At the same time, you can give the radius of this circle by giving dimension radius. You have to select the circle and then click over here. So this is radius 25. Now you have obtained the front view of the second step. Now obtain the top view of the second step just by projecting each and every point which are there on this front view by vertical straight line. So the command name is L enter. Then from this vertically downward, again from second point, use spacebar for repeating the command. So your one hand should be on the mouse and one hand should be on keyboard for using spacebar. Then similarly, all the lines from the previous top view. So we got all the horizontal and all the vertical projectors here. Now, first of all, label each and every intersecting point. So intersecting of projector A dash and A. Similarly, B dash and B likewise. So now use PO point command enter. So this is A projector and A dash projector. So A projector and B projector is the same. and here A dash projector. So here I've got point A, it will be point B, this is point C, this is point D, this is point E, this is point F, this is point G, and this is point H. If you practice, you can easily understand how to get this point. So for getting these points, you have to compare the projector of front view and projector of respective top point. Now after getting these points, label these points by DT command, DT enter, and the click location where you want the text. Enter. Here I want. So this is A, this is B, this is C, this is B, this is E, this is F, this is G, and this is H. Then click outside of, you can click over here and you can type this as apparent fill. And then click outside and then escape. We want to, we have now only points. We have to join these points now and we'll get the oval shape over here. But before that, you have to make these all projectors by thin line, or you can say color line. Now no need to use again color line because you already have drawn some lines over here in the previous view by color line. Instead of using color line directly, do it by match property. So match property means you take this brush which is there on standard toolbar and then select the color line which you already drawn over here and then click on the line that you want to. But if you go line by line, it will take time. So instead of that, you just select green rectangle like this and select green rectangle like this, and then you can convert all lines in one click. Then escape button. Now join these all points sequentially by polyline method. Now why polyline? Because we want a single entity. If you go by line command, simple line command, it will be discontinue, or you can say not group the object. It will not behave like a group object. So instead of that, use polyline command. You can press PL enter, polyline enter, and then A point, B point, C point, D point, E point, F, G, H, once again, and then escape. So this is the entire group. Instead of polyline, if you draw it by line, it will not act as a group. Because now we want to change it to the smooth curve. Right now it is not a smooth curve because this we have drawn by line. Now we want to convert this in smooth curve. Now how to do that smooth curve? You have to select this entire figure by selecting left click on that line, then click right. It will give the option, third option, that is polyline edit. Select that polyline edit and simply press a fit. Click fit option over in the list. It will generate a smooth curve. Now, once it generates the smooth curve, you can now match property. You make it thick by selecting this thick curve over here and then press on this. So it will give you thick smooth curve. So now the second step is over. Now see, in the problem statement, it is mentioned that third step, top view diameter is inclined at 45 degree with VP. So top view diameter means this one, which is passing through the resting point. So resting point is A. So top view diameter is now A. I'll just highlight that top view diameter by some other color. So AE is the diameter top view. I'll make it thicker and I'll make it magenta color. So this is top view diameter AE. Now this diameter AE is making an angle 45 degree with VP. Now how to make it? Right now, if you see, top view diameter A is parallel to XY line, and we want to make it at 45 degree. So you have to copy this top view now by CO enter, CO enter. Select the object by this option. Click one click over here and second click over here so that the entire figure and labels should come inside this blue rectangle. Second click. So now this object will get selected. Then compulsory right click and the point, sorry, you enter, select it, right click, and then select a point and place over here and then escape. So this is the copy command. Now, as I said, now here AE is parallel to XY line. Now make it at an angle 45 degree. So command name is RO enter, RO enter. Select object, same method, right click and select the point through which you want to rotate. So since we want to rotate AE by 45 degree, now this could be a clockwise or anti-clock. So now you can press 45 degree or you can press -40, not an issue. So 45 degree, then 45. So this is how you have to rotate. So now if you see this dimension, angular, angle between this and this is 45. Understood this? Now project all these points vertically upward and project all the previous front view horizontally towards this. So step by step, we'll first of all project all the top view points vertically upward by line command. L enter from point A vertically upward, space bar, then point. So this is how you have to project all the points from the front and all the points from the top. Now you enter and mark all the points. So A will be here, B will be here, C will be here, D will be here, then E will be here, then F will be here, then G over here, then H will be here. Okay. So now join this by polyline. So select PL, enter, and you have to join this and then convert into polyline and then fit. So this is the final view. Then do the match property, select this and this. So this is the final view. Now you simply label these points. So DT enter, enter, enter. So this is point A, this is B, so this is B, this is C, this is B, this is E, this is F, this is G, this is H. Now you can do the match property, select this point and select all this. So this is the final view and we have solved this problem on projection of circular plane. So just remember all these commands: line, DT, circle, divide, properties, copy, rotate, dimension, angular, align, polyline, match property. Thank you.